Good morning, everyone. My name is Stefano from the class of 11 IPA. Today, we will be discussing a topic in physics, which is thermal physics. So without further ado, let me screen share my presentation first. So thermal physics. Today, we're going to discuss the terms and conditions which will introduce you thermal physics. So we will get a better understanding later on. Then the second table of contents is classification of the thermometer. So we're going to discuss the thermometer according to the use and also according to the function. Then we're going to discuss the units of temperature. There are different types of units of temperature. So there are 5 of them, and we're going to discuss them one by one in detail later on. Then we're going to see some example or problem solving when we are converting one units of temperature to another units of temperature. For example, when we are converting Celsius to Fahrenheit, from Fahrenheit to Reaumur, or so on and so on. First, we need to introduce ourselves to thermal physics. There are some terms and definition. So the first one is heat. So what is heat? Heat is the transfer of energy from one particle to another particle. The second one is thermal energy. Thermal energy is the energy that is generated and transferred by heat. This heat and this energy takes place into a form of average kinetic energy. This kinetic energy is caused by the movement and the collision of particles or molecules. Now, to measure the thermal energy, we need the terms called temperature. So, temperature refers to the measure of the thermal energy, which is the degree of hotness or coldness of a body. Then we're going to move on to thermometer. So, we're going to discuss the different types of thermometer according to their use and also according to what liquid being used inside of the thermometer, right? But before we are discussing the type, we need to know the definition first, right? So thermometer is an instrument. Usually, it is measured and indicates temperature. It is the function, right? Then typically, a thermometer consists of a narrow silk glass tube marked with radiation and having a bulb at the end. The bulb contains mercury or alcohol. This mercury and alcohol expands and contracts in the tube with heating and cooling. Now we are going to discuss the different types of thermometer according to their use. There are 3 types of them. First, clinical thermometer. The clinical thermometer is measuring the body's temperature. So it is used for measuring the human's body temperature. They are accurate and sensitive. Also, they have a narrow place where the mercury level rises fast. Then the second one is laboratory thermometer. The laboratory thermometers measures temperature with a high level of precision. Why do laboratory thermometer needs to measure the temperature with a high level of precision? Because it is used for applications such as experimenting, right? It is used for calibration, it is used for materials testing and others. To maintain this work environment, to have this sterile work environment, we need a thermometer that measures temperature with a high level of precision. Now, atmospheric thermometer. So atmospheric thermometer is a device that measures the temperature of the indoor or outdoor air. Besides that, it also can measure the Earth's atmosphere. Then this is the picture of the clinical thermometer, of the atmospheric thermometer, and also the laboratory thermometer. Now we are going to discuss the thermometer according to the liquid that is used. First, mercury thermometer. The mercury thermometer is invented by Daniel Gabriel Fahrenheit. So the thermometer consists of a bulb. This bulb contains mercury and it is attached to a glass tube, which has a narrow diameter. This mercury expands with a rise in temperature, causing a thin thread of mercury to rise in the tube. So when there is a rise in the temperature, the thin thread of mercury will also rise. Then there is the alcohol thermometer. So alcohol thermometer is the alternative to the mercury thermometer. The alcohol thermometer consists of a glass capillary tube, which is marked with degrees Celsius or Fahrenheit degrees. Now the alcohol thermometer of course contains alcohol. This alcohol rises or falls as it expands or contracts, which changes in the temperature. Now this is the example of the mercury thermometer, and this is the example of alcohol thermometer. Now we're going to discuss the units of temperature. As you all know, there are 5 different types of temperature. First, Celsius scale. So Celsius scale is the most used scale in worldwide, right? Because it is very easy to use. And usually we measure our body with Celsius scale. But in the West, it is more often to use the Fahrenheit scale because it is easier for them to measure the temperature with Fahrenheit scale. Now the third one is Kelvin scale. The Kelvin scale is the international measurement for temperature. The fourth is Raymond scale. The fifth is Fahrenheit scale. Maybe some of you still don't know what is Fahrenheit scale because in the previous lectures, we only studied about 4 of these. And that is why today we're going to learn in more details about the units of temperature. So the first units of temperature is Celsius. The Celsius scale was found by Anders Celsius. Now, as I mentioned earlier, it is very worldwide known. Why? Because it is very easy to use. It's very easy to remember because the freezing point of Celsius scale is 0 and the boiling point is 100. So subtracting 100 to 0, we already found the range, which is 100. The second one is Fahrenheit scale. Fahrenheit scale was found by Gabriel Daniel Fahrenheit. The freezing point is 32 degrees of Fahrenheit. Meanwhile, the boiling point is 212 degrees of Fahrenheit. It is the same to find the range. We subtract the boiling point and the freezing point. So 212 degrees of Fahrenheit minus 32 degrees of Fahrenheit, we have 108. Next, the Kelvin scale, the international measurement. Kelvin scale was found by William Thomson. William Thomson, also known as Lord Kelvin. The freezing point for Kelvin scale is 274. Meanwhile, the boiling point is 373. Range is boiling point minus freezing point, 373 minus 273. We got 100. Reaumur scale. The Reaumur scale was found by Green Antoine Verhelst de Reaumur. The freezing point for Reaumur is 0 degrees of Reaumur. The boiling point is 80 degrees Reaumur. Now, to find the range is 80 minus 0, and we will have the range of 80. Next, the fifth, the Rankine scale. Now, the Rankine scale was found by William John McFarland Rankine. The freezing point for Rankine is 492. The boiling point for Rankine is 672. So to find the range for the Rankine, we have 672 minus 492, it's 180. Now to convert a unit of temperature to another unit of temperature, we need a formula. This is also known as the conversion formula. So here we notice some letters T, F, R, and R. So what are these, right? So T stands for temperature. We are usually given or we are asked to find the temperature. FR, FR here stands for freezing point over R, which is the range. So first example, 595 Reaumur 2 degrees of Celsius. I mean for 595 Fahrenheit 2 degrees of Celsius. You can see the formula right here. So the temperature of Rankine is here, 595. Then we insert this, right? The freezing point for Rankine just now is 492. Meanwhile, the range for Rankine is 180. So we can get the temperature of Rankine minus 492 over 180. And we are asked the temperature in degrees Celsius, right? So temperature in degrees Celsius minus the freezing point of Celsius, which is 0, over the range, which is 100. Then we insert the temperature that is given, which is 595.5 here in the formula. Then one thing that you could do is to cross multiply them. So 595 minus 492 times 100, which is also equals to 180 times temperature of degrees Celsius minus 0. 595 minus 492 is equals to 103 times 100 equals to 180 times the temperature of Celsius is 180 temperature of Celsius. Then we multiply 103 to 100. 10,300 is equals to 180 temperature of Celsius. Now we are going to find the temperature of Celsius by dividing 10,300 to 180. We get this number, which is 57.22. Now we round the 57.22, 57 degrees of Celsius. Why? Because this whole question use whole numbers, right? So it is mandatory for us to round the number also to the whole number. Next, converting 95.5 degrees Reaumur to degree Fahrenheit. Now, we are asked to find the degrees in Fahrenheit, right? So here, minus the freezing point of Fahrenheit, which is 32, over 100, because 112 minus 32 is 180. So we have the range, and Reaumur, it is already given. The temperature of Reaumur is already given, so insert it. 95.5 minus 0, which is the freezing point of the Reaumur, minus the range, is 80. Now, if we are going to cross multiply this, the number will be very large, and it is very hard to count, right? So notice that I'm going to divide these numbers by 20. 180 divided by 20 equals to 9. 80 divided by 20 equals to 4. Next, we can cross multiply them like we do just now. So degrees of Fahrenheit minus 92 times 4 equals to 9 times 95.5. Then we get 4 degrees of Fahrenheit minus 4 times negative 32 is negative 108 equals to 9 times 95.5 is 859.5. Then we will get the temperature of Fahrenheit, which is 809.5. We plus it to 128 and divide them by 4. Then we get 146.875. Then don't forget always to follow the significant rules so that you will get the precise answers. So here, because there are 4 figures, we also use 4 figures. So we round it off to 246.9 degrees of Fahrenheit. And this is all for today's lesson. And this new meeting, and see you next time. Thank you.